What is first-order stochastic dominance? Well, in this video, I'm going to give a high-level overview so you understand the concept behind first-order stochastic dominance. Now, first-order stochastic dominance is a decision theory that compares two alternative choices. Like in this example, we've got investment portfolios. We don't make any assumptions about the decision maker's risk preference. All right, that's very important. And we don't make assumptions about anything else. The only thing we assume is that the risk taker prefers more good versus less good. With that in mind, let's go ahead and take a look at these different portfolios. We've got portfolio 1, portfolio 2. So this investment portfolio 1 says we've got a 25% chance of making, let's say, $5, a 50% chance of making $3, and a 25% chance of making 0. Over here, portfolio 2, a 25% chance of making 0, a 50% chance of making 2, and a 25% chance of making 4. Now, I'd ask you, which one is a better investment portfolio if you prefer more good? Well, over here, we've got 25% chance of making 0, matches this. A 50% chance of making 3, that's higher than the 50% chance of making 2 on portfolio 2. And then a 25% chance of making 5, which is greater than 25% chance of making 4 on portfolio 2. So it seems that portfolio 1 is the clear winner. Now let's try this other one. We've got portfolio 3 and we've got portfolio 4. Portfolio 3, a 10% chance of making 0, a 50% chance of making 2, and a 40% chance of making 4. Portfolio 4 offers a 25% chance of making $0, a 50% chance of making $2, and a 25% chance of making $4. So again, I ask, well, what's a better option? Well, over here, we've got a 10% chance of making 0, which is lower than the 25% chance to make 0. So far, this one's a little bit better. A 50% chance of making 2, which matches that. So we're still even at portfolio 3 being the better option. And then 40% chance of making 4 versus 25% chance of making 4. So I've got a higher probability that I'll make more than on portfolio 4. So portfolio 3, right over here, is the clear winner. Now let's keep this concept in mind when we start solving first-order stochastic dominance problems. Now I want to graph portfolio 3 and portfolio 4 as CDFs, or cumulative distribution functions. So let's go ahead and do that. Here we've got portfolio 3 as f of x, and then over here we've got portfolio 4 graphed as g of x with their corresponding colors here on the graph. Now, although these portfolios have discrete outcomes, we can still derive a CDF for each. Now, the CDFs will be a step function, as we see here, increasing at each outcome by the probability of that outcome. All right. So over here, let's start with portfolio 3. We see a 10% chance of making 0. So over here, it increases by 10%. Then we've got a 50% chance of making 2. So at 2, we increase by 50%. And then we've got a 40% chance of making 4. So at 4, we increase by 40%. Same with g of x over here, a 25% chance of making 0. So it increased by 25%. They're at 0. A 50% chance of making 2. So at 2, it increased by 50%. And then we've got a 25% chance of making 4. So at 4, it increased by 25%. So here we have them graphed as CDFs. Now we are looking for the function that is always on or below the other function. So we take a look over here and we see that these two functions are touching, so that's on each other. Over here we see that the f of x is actually below g of x, and over here we see, of course, that f of x is below g of x. And then over here, we see that they're again touching. So we're always trying to find the function that is on or below the other function. So over here, we would say that f of x, since it's on and below g of x, is first order stochastically dominating g of x. All right? That's the basic idea behind FOSD, first order stochastic dominance. If one alternative, one option, one function right over here, one alternative, in this case portfolios, first order stochastically dominates the other, its CDF must be equal to or less than the other alternative's CDF at every single point. And at every single point, they're either touching or f of x is below g of x. So now, the whole point of FOSD is that any utility maximizer, regardless of their risk preferences, so we don't take in account if they're risk adverse, if they're risk loving, if they're risk neutral. We don't take account any of that. Regardless of the risk preference, they would pick the alternative, or in this case the portfolio, that first order stochastically dominates the other. So in this instance, any utility maximizer would pick f of x over g of x because it first order stochastically dominates g of x. Now these two functions cannot cross. Why? Let me explain. Over here we've got a random f of x and g of x. Now pretend they're two different alternatives, and we've graphed them out. So over here at this point I see, hey, g of x is first order stochastically dominating f of x. But I come here a little bit further and I see, well, actually now it's backwards. F of x first order stochastically dominates the other. And then I come over here and I see, well, now it flipped a little bit. Now g of x first order stochastically dominates the other, right? So we're flipping back and forth. Now the reason why crossing doesn't work is because people will make different decisions based on their risk preferences. So you might not always choose f of x as opposed to g of x. And you might not always choose g of x as opposed to f of x. One person will say, hey, I think g of x is a better option. The other person will say, no, I think f of x is a better option. Since there is no alternative that is objectively better, and there is no unanimous preference, which is exactly what FOSD requires, then we say that no first order stochastic dominance exists. And that is why they cannot cross. FOSD requires one CDF to always be below or equal to the other. Now, as a recap, the whole point of FOSD, first order stochastic dominance, is to help decision makers identify which alternative from the two is objectively better, without needing to know their exact preferences or their risk attitudes, as long as they prefer more good versus less good. Now, it's a decision theory that provides this, you can call it universal ranking for all decision makers who believe that more good is better. And it simplifies things because most people believe more good is better. So I hope this video was helpful. If it helped you, let me know in the comments below. If you've got any questions, let me know. I will try to address them. And as always, stay positive.